MotorGuide R3 with 30 pounds of thrust. Lachy 12 volt 18 amp hour lithium iron phosphate.
Let's put these two together and answer all the important questions. How fast, how far, how much? Hey everybody, AJ here, and welcome back to the Eagle Ray channel where we do all things DIY electric boats. Marine motors, batteries, solar panels, you name it. If it's got volts and it's on a boat, you're in the right place. Today, we've got another 30-pound trolling motor we're gonna look at. The MotorGuide R3 is a close competitor to the Minn Kota Endura, which we've tested recently. I picked up the MotorGuide on Amazon in February 2023 for 120 bucks, which is 10 bucks more than I paid for the Endura on a Black Friday sale. But the Endura was $30 off at the time. The current best price for the Endura is $140, $20 more than the MotorGuide. However, you see this knob right here? That is the heading adjustment, and I had a lot of trouble with this knob, as we're going to see a little bit later. But we'll give the MotorGuide a fair shake anyway, because I don't like to play favorites. On the Eagle Ray channel, there are no sponsorships from either motor or battery brands during these tests, so you can rest assured the numbers are accurate and unbiased. And to power the R3 today, we have a 12 volt 18 amp hour lithium iron phosphate battery from a company named Lachy. Honestly, I've never heard of this brand before. The graphics on the battery are pretty low quality in my opinion, so I wouldn't be surprised if this is just some fly-by-night brand that won't exist in a few years. But you know what? If the battery is a good price and the cells actually work, I'm here for it. So let's waste no time and get straight into a full throttle bench test. Are you ready? It's time to send it. There are cheaper lithium batteries on Amazon, but not in this class. Specifically, I'm talking about the 20 amp hour class because this battery is 18 amp hours. It's close enough to 20 that I kind of consider it in the same category as all the other 20s. Most of the sizes that you'll find in around this range are going to be 20 amp hours. So if I'm looking for the cheapest lithium pack, why didn't I go with something even smaller, like let's say a 6 amp hour pack? Because some people do use them that size for, let's say, kayak electronics. The thing is though, I want to see what these batteries can do when you plug them into a motor. And if you tried to plug a 6 amp hour pack into a 30-pound thrust motor, even though that's one of the smallest motors on the market, that MotorGuide is far too big for a battery that small. How do you match battery size to motor size? Step 1, check the motor's user manual. A well-written manual would show maximum amp draw somewhere. In the MotorGuide manual, I couldn't find it anywhere, but I was able to locate it in an R-Series marketing brochure I found in a quick Google search. See, here it says the MotorGuide R3 has a max amp draw of 36 amps. That's actually a bit high. On the bench test, it never goes above 28 for us, but it might be able to hit 36 if we overvolted it. We're gonna save that for another video. Step 2, compare the max amp draw from your motor to the amp hour rating on your battery. The max amp draw from your motor is the maximum current that it's ever going to try and pull out of the battery. So if that number is at or below the battery's amp hour rating, then you're probably good to go. If it's above that number, then you might be in the danger zone, but not necessarily. Most motors don't operate at peak all day long, so if your lithium battery needs to push more amps than its listed capacity, it can usually do a certain amount of that within reason. It's called overdraw. In our case, we have an 18 amp hour pack, so we know it can push 18 amps continuous without any trouble. We call that 1C discharge rate. But until you hit the resistance limit of the battery, it's the motor that gets to choose the draw, even if it's overdrawing above 1C. Will the battery refuse? At some point it will, because any battery can only give as many amps as are physically possible based on its internal resistance. So there is a limit, but the ultimate limit is usually quite a bit higher than the capacity rating on the box. You'll hear people talk about overdrawing at discharge rates of 2C, 3C, etc. sometimes. There's potential danger in overdraw. Generally, when you're using a LiFePO 4 battery, when you're above 1C, it's kind of at your own risk. The manufacturer and seller will typically stand by a 1C rate or below, which means for this battery, 18 amps and below is good to go, but this motor is gonna pull more than that. Even though Lachy only stands behind 18 amps, we're pulling around 25 right now and the battery's not complaining. 25 amps divided by 18 amps is about 1.4C, and so the big question is the MotorGuide asking too much of this battery at 1.4C? And we answer that by monitoring the heat. If this battery heats up beyond about 130 degrees during a discharge, then we know the MotorGuide is pushing it too hard. If we were pulling at 2C or 3C, that would probably be the case eventually, but at 1.4C, we might be working the battery just hard enough so that it gets a little bit warm by the end of the discharge, but is still maybe okay. If you're gonna overdraw your batteries, I highly recommend you use a temperature sensor while you do it. You can get a cheap one at the hardware store where it points a laser beam at the target and it'll tell you the temperature of whatever you're pointing at. Or you can go super high tech and get one of these FLIR devices. It's a heat camera that plugs into your iPhone, and then when you point your phone at anything, you'll get a camera feed where every single pixel will give you a temperature. We've been pulling 1.4C for almost an hour now, and the internal temperature of the battery is doing well. It's come up by about 10 degrees so far, which is not bad. The hottest spot you can see is right on the terminal connectors, where it's about 105 degrees Fahrenheit. It'll be warm to the touch, but obviously not going to burn your skin. So we're going to keep an eye on this through the rest of the test. Before we jump to the end and check out the results, I think we should zoom in on this tiller handle. You see that drift? Yikes. I had to retighten the heading knob 3 times during this test. I had to use both hands and it needed to be so tight I felt like I was gonna break it. As we close in on a full discharge, I just want to draw your attention to the benefit of lithium iron phosphate. It says 174 at the bottom right corner here. That's 174 watt hours. That means this battery is 75% depleted and it has been above 12 volts right up until this moment. That's why people love lithium iron phosphate on boats. It has less voltage sag than most other types of batteries. And now the full throttle test is done and we've got some results. As you've seen in previous videos, the Drock monitor here tells us the energy we were able to pull out of the battery in the lower right corner. So the Lachy activated over discharge protection, and the frame right before that, it was showing that we were able to pull a total of 211 watt hours. Lachy promised us 230.4 watt hours or 0.23 kilowatt hours, and what we got was 211 watt hours or 0.21 kilowatt hours. That is a negative difference of approximately 8%. But honestly, I kind of expected this shortfall because that is typically what happens with overdraw. As voltage depletes toward the end of a discharge, overdraw will cause the voltage to fall off faster at the end than if you were at a 1C discharge rate. So because we were at 1.4C during this discharge, we saw the battery's fuel tank contract by about 8%. And that's to be expected. That's called the Pukert effect. I didn't just buy this motor so we could run it on the bench. Let's take it out to the lake and see what it can do in the real world. Are you ready? It's time to send it for real. I'm really curious to see if the R3 does any better than the Endura did. In a previous video, we got caught in some high wind and current during the lap around the island here on Lake Havasu, and we had to turn back. We never made it through our planned route under the London Bridge, so we're about to see if MotorGuide can finally get us there.
There's the Lachy Lithium and the R3 working hard on full throttle. It feels honestly very similar to the Endura. I can't really tell a difference between the Endura with the chins versus the Lachy on the R3. It feels exactly the same.
The Lachy didn't get us very far, but we kind of expected that. That's why I brought a bunch of backup batteries. So before we go to the final results, check this out. We finally made it to the London Bridge. It's time to look at the final results. The R3 turned out to be the exact contender that I thought it was going to be. The components are high quality. They feel very similar to the Endura that we tested a few weeks ago. In fact, I don't really have any preference between the two of them. A couple of weird quirks did get in the way when I was testing both of these motors. Let's talk about the MotorGuide first, because this motor, when I found it on Amazon, it said it was a 36-pound troller, and I was excited to see if there was a difference between it and the Endura, which is 30 pounds. But when this showed up, it clearly says 30 pounds right on the case. So that was a little bit annoying, and when I tested the output power, they're basically identical between the two. These are essentially the same motor across the board. This one actually has 7 speeds, 5 forward and 2 reverse. This one's supposed to have 8 speeds, 5 forward and 3 reverse. But the thing is, the third reverse speed broke on this one after I had been using it for only like a month and a half.
So actually, right now, these two motors both have only 7 speeds. The Lachy is nothing if not consistent. We got 205 watt hours on the test bench, 204 watt hours out on the lake. Now that's 8% below rated capacity in both cases, but we did overdraw the capacity by 40% in both cases. So you can't really blame a small battery like this for buckling under the pressure of 300 watts. Now the MotorGuide did a consistent 24 amps continuous on average, which is the exact same number we got from the Minn Kota a couple of weeks ago. But because we were running on a tiny battery this time, we would have been stranded out on the lake after just 45 minutes if we didn't have a backup. That said, weather matters a lot because this time it was glassy the whole way through. No wind and no current. It made a huge difference for the speed. The average speed was 2.5 miles per hour for the MotorGuide. That's all we have time for this week, but next week I'm going to take this Lachy and I'm going to put it head to head against an AGM battery of the same size to see how they fare against each other. So if you want to see that, hit the like button, hit subscribe, join us in the live stream on Sunday at 2 p.m. because I'm still giving away this Milwaukee angle grinder as soon as we reach 1,000 subscribers. Rules are in the description, and remember to get out there and enjoy yourself on the water this week. Until then, boat safe, take care.